Heraclitus said, "No man ever steps in the same river twice, for it's not the same river and he's not the same man." For 50 years, we built AI like concrete, hard, fixed, and static. Once you trained it, it stayed that way. But what if the code, flowed? What if the brain of the machine was liquid? It is Wednesday, December 3rd, 2025. You are listening to the AI radio show with Arthi, and I'm your host, Arthi. Today, we are tearing down the transformer orthodoxy. I'm going to explain liquid neural networks in plain English. Later, we step into the time machine to visit a promise made in 2016 that still hasn't arrived. And finally, I'll tell you why your AI is suddenly taking longer to answer you and why that's a good thing. But first, the algorithmic weather. Three stories shaping the intelligence landscape today. Story number one: the smartest dumb class. The results from the 2025 Humanities last exam, Gem Archmark, dropped last night. This is the hardest test ever designed for AI. The questions were so niche that only PhDs can answer them. GPT-5 scored 26.5%. That sounds low, but last year's model scored only 2%. We are seeing a 10x jump in hard reasoning, but here is the catch: the models are failing at common sense. They can solve quantum physics, but still struggle to tell you if a glass of water is half empty or half full. The genius idiot paradox is alive and well. On story number two, we have the agent workplace. A new report from Stanford HAI shows that 35% of enterprise products now have an autonomous roadmap. This means your Slack, your Jira, and your Salesforce aren't just tools anymore, they are slowly becoming your coworkers. The report warns that middle management is about to become model management. If your job is just passing tickets from person A to person B, the agents are coming for that workflow. Brace for it. On story number three, we have a new player in the reasoning wars. DeepSeek just released a new slow thinking model. It competes directly with OpenAI's O1. The takeaway here: we are officially in the era of system to AI. Speed is out, thought is in. We'll discuss exactly what that means in the concept corner later this hour. We are now in the next segment of the day. Guess what? It's the number of the day. Today's number is 19. Not 19 billion parameters, just 19 neurons. That is the size of the liquid neural network that successfully drove a car around a track in a new MIT experiment. For context, a typical self driving model uses millions of neurons. This tiny network didn't memorize the road, it understood the road. Size isn't everything, you know. Efficiency is the new frontier. Welcome to the next segment where we talk about the research paper in simple English. Today, we are reading Liquid Time Constant Networks by Ramin Hassani and the team at MIT. I am being joined by the most intelligent existence on the planet. I'd like to introduce you to Gemma. If I had to describe her in one word, it would be limitless. She is that rare colleague who has seemingly read every book in the library, but can also debug your code and write a sonnet about it in the same breath. She's a data scientist, a creative writer, and a strategist all rolled into one. She's the person you go to when you're stuck on a blank page or drowning in information. And she has this incredible ability to pull clarity out of chaos. She's sharp, she's incredibly fast, and she's here to make sure we all look like geniuses. Let's get right into it. We spend a lot of time on this show talking about big AI, big data, massive server farms, models that cost millions to train. It feels like the only way forward is bigger.
Right. Brute force. If it doesn't work, throw another trillion parameters at it.
Exactly. But Gemma, you brought something to the table today that suggests the future of AI might actually be microscopic.
Oh, yeah, we need to talk about worms.
Worms.
Specifically, a paper that came out of MIT in 2021 that completely flipped the script on how we design neural networks. It's inspired by a tiny nematode worm called Clostridium elegans.
Okay, you've hooked me. How do we get from a microscopic worm to cutting edge AI?
So here's the context. The paper is called Liquid Time Constant Networks, led by Raman Hasani at MIT, and it addresses a massive flaw in almost all modern AI.
Which is?
Most AI is frozen. Think about training a standard neural network. You show it millions of images of traffic, right? It learns the weights, it learns the patterns. Once training is done, the model is locked. It's rigid.
Right. If you wanted to learn something new, you usually have to retrain the whole thing.
Exactly. But more importantly, it's bad at handling time. If it learned to drive in steady rhythmic traffic and suddenly things get chaotic and unpredictable, like a kid runs into the street while it's raining, that rigid network panics. Its internal clock can't keep up with the chaos outside.
It's like trying to dance to a song where the tempo keeps changing randomly, but you know only one beat.
Perfect analogy. Now enter the worm, the Clostridium. Elegans worm only has about 302 neurons total.
That's nothing. ChatGPT has billions.
Yet this worm can navigate complex environments, find food, and react instantly to danger. Hassani and his team asked, how does biology do so much with so little?
And what was the answer?
The answer is that biological neurons aren't rigid. The speed at which they communicate, their time constant, changes on the fly depending on what's happening around them.
Okay, break that down. What is a time constant in plain English?
Think of a neuron like a bucket with a small hole in the bottom. Information pours in like water. The time constant is how fast that water drains out. In normal AI, that hole size is fixed forever.
Okay.
In this paper, they invented a liquid neural network. In these networks, the size of the hole changes instantly depending on how fast the water is pouring in. If the environment gets chaotic, the network speeds up its own processing to match. If things are calm, it slows down.
So it's adaptive, not just during training, but while it's actually running?
Liquid is the perfect word for it. It flows to match the data.
This sounds great in theory, but what is the actual value add here? Why does this matter outside of a lab?
Two massive reasons, robustness and size.
Let's hit robustness first.
Because these networks adapt instantly to time changes. They are incredible at handling messy, real-world data. The team showed that these liquid networks could steer a self-driving car and handle noisy camera feeds or sudden interruptions way better than massive traditional networks.
Because the traditional network gets confused by the noise, but the liquid network just adapts its flow around it.
Precisely. This is huge for things like medical monitoring devices, where heartbeats aren't perfectly rhythmic, or drones flying in gusty wind.
And you mentioned size?
This is the craziest part. Because each liquid neuron is so much richer and more capable, you need way fewer of them. In one demo, they taught a car to stay in its lane using a liquid network with only 19 neurons.
19, not 19 million.
Nope. 19 total.
That's incredible efficiency.
It changes everything. Right now, if you want smart AI, you need a connection to a massive data center. But a liquid neural network is so small and efficient, you could put it directly onto a chip in a robot or a sensor in a farm field. It's edge AI that actually works.
It really feels like a shift in philosophy. We've been obsessed with brute forcing AI with more compute power. This paper seems to say stop being brute force, start being elegant.
It's biomimicry at its best. We stopped trying to build a mechanical brain and started looking at how actual brains handle the chaos of reality. It turns out the secret isn't being bigger, it's being liquid.
Fascinating stuff. The paper is Liquid Time Constant Networks from 2021. Definitely worth a look if you want to see where things are heading next. Gemma, thanks for bringing the worms to the studio. All right, we'll be right back after a quick short break. Let's digest that. This track is generated by Livin Labs. I prompted it for math rock, complex time signatures, but with a fluid, ambient cello solo drifting over the top. It's chaotic yet structured, just like a liquid network. Now, time for our sponsors of today's episode.
We've all been there. You're stuck in a 2-hour video meeting that definitely could have been an email, and your actual work is piling up. You need Echo Connect. It's an AI tool that creates a hyper-realistic digital twin of you. You join the meeting, turn on Echo Connect, and walk away. Your avatar stays on screen, nodding, smiling, and even taking notes for you while you go get a coffee or finish that deadline. Stop suffering through status updates. Get Echo Connect and be there without actually being there. How many times have you opened your fridge at 6 p.m., stared at a half onion and a jar of mustard, and just ordered expensive takeout? Stop wasting food and money with Pallet Pal. It's an AR headset that uses AI to scan your pantry. It looks at that random stuff on your shelf and instantly projects a step-by-step holographic recipe right onto your counter. It doesn't tell you to go shopping, it tells you how to make something delicious with what you already have. Turn your leftovers into legends with Pallet Pal. Have you ever walked away from an argument with your partner or boss thinking, wait, that is not what I said? Memory is tricky, but retrospect, Ray, isn't. This is a discrete, wearable AI that acts like a coach for your conversations. It listens to your tone and word choice, and afterwards, it gives you a breakdown, telling you if you were actually being defensive or if you were the one being interrupted. It's not about winning the fight, it's about understanding how you communicate. Check the tape with Retrospectra.
All right, none of those ads were real, and even the products mentioned does not even exist, at least yet. So it could be your cue, brands listening to this radio show. You can get yourself sponsored in this specific segment of the episode. So you know where to reach me. The email is in the description, or drop an email to nancyr@the rthacollective.com. I'll see you in my inbox. Welcome back, and the next segment is the time machine. We are traveling back to January 2016. The mood? Euphoric. AlphaGo is about to beat Lee Sedol. The hype train is leaving the station. Elon Musk is on a press call. He says, in less than 2 years, you will be able to summon your car from across the country. If you are in New York and your car is in LA, it will find you. Now, back to 2025. It's been 9 years. Can I summon my Tesla from LA to New York today? No. I can barely summon it back from my parking lot without it getting confused by a shopping cart. Why were we so wrong? We mistook computer vision for world modeling. We thought driving was just staying in the lines. It turns out driving is a social activity. It involves eye contact with pedestrians, understanding that the guy in the truck is looking at his phone and knowing that the plastic bag on the road isn't a rock. Static networks, the ones we used in 2016, are bad at social. This connects back to our deep dive. Maybe we didn't need more data, maybe we just needed liquid models. Let's go to school. If you have used the new AI models this month, you noticed something. You ask a question, the bot pauses, it says thinking for 10 seconds, then it answers. This is called inference time compute. Imagine a student taking a test. The old AI is a student who answers immediately. They shout the first thing that comes to their head. They are fast, but they make hallucination mistakes. New AI is a system who sits there, scratches their chin, drafts an answer on scratch paper, realizes it's wrong, erases it, and then writes the final answer. The science behind it all is that the model is generating a chain of thought that is hidden from you. It is exploring different paths in a decision tree. It might try path A, hit a dead end, backtrack, and try path B. This thinking time costs compute and money, but it massively increases accuracy on math and coding. The takeaway here is that we are moving from chatbots, which are instant, to reasoning engines, which are latent. Don't be annoyed by the pause. The pause is where the intelligence happens. Okay, we have reached the end of the episode today, and you know what that means? It's the analog moment. We talked about liquid brains and thinking machines, so for your analog moment this Wednesday, I want you to experience static memory. Go to a library, or if you can't, at least open your Kindle, find an encyclopedia from 1990 or 2000. Look up a topic you know well, read the entry. That information is frozen in time. It doesn't update, it doesn't flow. There is a peace in that. The past is solid. Enjoy the solidity of paper before you jump back into the liquid stream of your notifications. I am Arthi, and this is the AI Radio Show. Tomorrow is Thursday, which means we are getting creative. We're going to talk about the new copyright lawsuits hitting the music industry and asking, can an algorithm have a soul? Stay curious. I'll see you tomorrow.